All right, guys. So today I'm going to spend a little bit of time going over our lab data that you should be able to pull up on Schoology. All of you guys should see something where it says student data crystal violet lab, and you guys should be able to pull up this Google Sheet. Make sure you guys go to file and then make a copy for yourself and don't write on the actual document itself. That way you won't be like messing up the original spreadsheet. So I want to show you guys what was happening over here. The question you guys are actually answering from the lab in your lab report is going to be whether changing the initial concentration of the crystal violet is going to impact the order in the rate law for this. So you guys are going to look at three sets of data that were taken over here. And the first set of data, you guys could see that we're looking at the crystal violet solution. It was at a 12.5 micromolar, so 12.5 times 10 to the negative 6 molarity for the concentration of crystal violet. That was reacted with a 0.02 concentration of sodium hydroxide, and I used 10 mils of each. Okay, so this was poured into a little beaker, it was stirred, and what's going to start to happen is once the hydroxide starts to react with the crystal violet, what it does is it takes off the positive charge from one of the carbons that we have in the crystal violet, and it goes from like that deep purple color that you guys remember seeing last week on Thursday over to clear. Okay, so that being said, the more violet it is, like less of the reaction has happened, the more clear it's becoming, more of the reaction has happened. So we could use our good old spectrophotometer to give us absorbance data because this is a reaction that produces a color change. Okay, so I started off at 40 seconds over here. I started the timer as soon as the two chemicals were mixed, but then I had to pour it into a cuvette and get it into the spectrophotometer. So you could see there was a little bit of a lag here. So we started collecting data at 40 seconds for every 20 seconds. And this is the data that you guys are looking at here. If you guys scroll down below, and this was done for close to 15 minutes. So this one looks like was 20 seconds before. If you guys look down here, right, for time versus absorbance here, the crystal violet used for this round was 20 micromolar, so 20 times 10 to the negative 6 molarity, and same deal, I use this with the same concentration of 0.02 molar hydroxide. They were mixed together and then put into the spectrophotometer. And again, you could tell that I wasn't fast enough to get it in there at 20 seconds. I started collecting data at 40 seconds. There were a few instances for this part where like I just kind of messed up and I wasn't paying attention. So I think there's like 2 points where like they don't go up sequentially. So it's like 460, 480. I don't know where it's at, but if you guys look carefully through the data, I'm actually, I missed like 2 of the 20-second intervals here, but it's okay. It's totally fine. And then if you guys look at the third set of data here, now we're looking at the same idea. The crystal violet solution here was a 25 micromolar solution. Again, same deal. I added it to 10 mils of the 0.02 molarity for the sodium hydroxide and then mixed it together, put it in the cuvette. This one, I actually got it to go at 20 seconds. So you guys could look through here and there's 3 sets of data for you guys to go ahead and analyze. What I wanted to do with you guys today is just show you how to actually use your Google Sheets as a way to take this absorbance data and easily calculate concentration versus the natural log concentration versus 1 over the concentration. And you guys remember an easy way to actually figure out what the order of something is you just take a graph of these 3 things. Remember, you guys have 0 order, 1st order, and 2nd order. So we're gonna compare the graphs for each of these. And again, you are gonna be using Google Sheets for everything. So you don't need to sit there and calculate all of these data points for all this. So what you guys should probably look at right now at this point is your lab sheet, where you guys wrote down the equation that you guys got from last week on Thursday for the calibration curve, right? So if you guys are looking at your equation, I think most of you guys should have had an equation like this, where it says y is equal to 0.0394x minus 0.022. Okay. And remember what the x actually stands for here. The x is your concentration of crystal violet, okay? And the y is the absorbance, right? So remember the whole purpose of doing like those, the 6 different solutions that you guys got last time was so that you guys could get an equation in which you could figure out the concentration of crystal violet as the time was passing in the actual reaction. And you guys should notice here that as time is increasing, the absorbance values are going down because more and more of the crystal violet is reacting with the hydroxide and you guys are getting it to turn clear. And the whole point of this lab is you guys want to figure out what is the reaction order for crystal violet. Is it 0? Is it 1 or 2 in terms of how it impacts the speed of the actual reaction itself for crystal violet turning clear with sodium hydroxide? So let me just walk you through the cells. If you guys are already pretty comfortable with this, you can kind of just skip ahead and look at the portions that you need to. But for you guys to turn absorbance into crystal violet, what you guys want to utilize is that equation that you guys wrote out on your lab sheet where you solve for the x using your equation of the calibration curve. Okay, so we have an equation like this. I have 0.022 plus absorbance divided by 0.0394. And if your equation's a little bit different than the one that I'm reading off, it is most likely because you did not include a 0, 0 as a part of your calibration curve data. So make sure you guys add that in. Okay, so I'll show you guys how you add this in. You're gonna hit equals, right? And we're gonna use parentheses and 0.022 plus click on the actual absorbance data point instead of typing in 0.197. You could also type in the cell, this is B2, right? So you guys could just click on B2 or you could just write B2. We're gonna close the parentheses and I'm gonna divide this by 0.0394 and hit enter over here, okay? And when you do, what you guys should see on Google Sheets is the calculated value for the concentration of crystal violet. Keep in mind too, guys, that the number that you guys are seeing, it's not 5.55 molarity, it's 5.55 times 10 to the -6 molarity right here, because we're looking at micromolar for everything. Okay, so you guys have a data point. You guys might have noticed that it says something about autofill. You should click check mark if your data does do that. But if yours doesn't, all you guys have to do is click on the bottom right-hand corner of the cell. You should see a cross come up out, and then you're gonna drag it all the way down. And what Google Sheets is gonna do for you is it's gonna do that exact same calculation that you did for this one cell for every other cell below it using like the corresponding data point that we have. Right, so this is an awesome way to calculate a lot of data using just one input of an equation. Okay, so move up, we're gonna do the exact same thing. We know the concentration of crystal violet. Now let's figure out what the natural log of the crystal violet concentration is. So one more time, make sure you guys hit the equal sign here. And then you're gonna just type in natural log ln. You're gonna see the ln suggestion. So I'm gonna hit enter for that and it should come out capitalized ln. For the parentheses, you want to natural log the crystal violet concentration. So I'm going to click on this right here on cell C2, close it and hit enter. And you guys can see Google Sheets is going to do a suggested autofill for everything and I'm going to accept it. Because pretty much they are dragging and dropping that equation all the way down for you. Nice, right? Same thing over here for 1 over crystal violet equals 1 divided by, we're gonna hit the crystal violet concentration here, 1 over C2, enter, and then again, take the suggested autofill, and you guys are done here, okay? For you to actually figure out now what kind of order it is, 0, 1, or 2, you wanna go through and turn this into a graph. So you guys are looking at the integrated rate law stuff that you've done with me, and you wanna go ahead and highlight time, because that's gonna be your x-axis. And the first graph you guys are going to create is going to be for the crystal violet concentration alone. So hit command and then select all this data here too. And make sure you guys always, when you graph this, you want to take the label heading, because that's Google Sheets' easiest way for it to understand like how to graph or what kind of graph you actually want. The chart. And there we go. So you guys have a graph like this, right? What you guys also want to do from here is you want to go to customize, go to series, and you want to hit trend line. Okay. And for this one, the label, I want the equation, and you guys want to show the R-square value over here. Okay, so you could see the blue, the dark blue are the actual points that we graphed. The light blue is a suggested line that you guys see here. And it looks pretty good, right? But let's see if we could do any better from looking at the other graphs of data that we have. So I'll go through that procedure really fast again. So one more time, highlight time. You're gonna also highlight natural log, crystal violet concentration. And same thing, we're gonna make a graph out of this. And this one was a little faster. So you guys have the natural log graph over here, right? And one more time, customize, you're gonna get a trend line here. And we wanna show the R-square value, and you want the equation. Okay, so I don't know if you guys could already tell. I know that to the naked eye, these like look pretty darn similar, right? But if you guys look really carefully, the natural log graph just looks better, right? Like the points themselves for the natural log crystal violet is almost like dead on with the suggested line that you guys have. And you could even see this like visually, like I don't see any parts where the line and the data points are really like offsetting each other. Like they seem to just lie right on top of each other over here. And the R-square value is another evidence point you guys could use. It's pretty high, meaning the line is a pretty good fit with the data that we have. Okay, and then one more time, we're gonna do the same thing. You're gonna take time. Ooh. Oh, I didn't mean to do that. Okay, let's do that again. They're gonna highlight time. And then we're gonna go ahead and also highlight the inverse crystal violet. Okay, and then we're gonna insert this in. Okay, so this is my graph right here. And then one more time, let's do what we did before. Hit series. You guys should get really good at making graphs after doing this lab. All right, and we have our equation of the line. You see our R-square is also pretty high, it's 0.99. But again, if you had to pick between the three graphs that you guys see here, you wanna pick the one that gives you like the most straight line. And I'll tell you guys, like typically when you guys analyze AP data, like the curves are a little more obvious, right? But for this one, like they're pretty close. So you just have to go and pick the best graph that fits your data point to get the straightest line, because these all look pretty straight to the naked eye, right? But I could tell here that concentration, there isn't that, it's not that great. The natural log looks like almost like dead on, right? And then for the inverse one, although the R-square value is quite high, like you could see like the like how the line and the data point don't do like a complete overlap like what you guys saw over here. So it gives you guys an idea for what the order is going to be for this data that we just analyzed. And you're essentially going to do the exact same thing for the 20 micromolar crystal violet. And then also looking at the 25 micromolar crystal violet. And your objective is to try to answer that question from the lab report, which is to say, does changing the initial concentration of the crystal violet do anything to the order of the data itself? Okay, and that's pretty much it. I think hopefully this will be of help for you guys, where you could kind of use this video to help you analyze the data that you guys have. I think this will be kind of a simple lab report to write up, even though there's a lot of data. I think most of it is just kind of figuring things out on Excel. And the lab will be due on Thursday. And by Monday, guys, I'll be putting up like the detailed rubric on Schoology for you guys. Like these are the things I would expect for you guys to discuss in your introduction or background info. These are the graphs I expect you guys to include. These are the calculations you need. So I'll kind of spell that out for you guys so you guys know what to expect for the lab report on Monday. And that's pretty much it for this. I'm going to go ahead and pause our recording for now so that I could get you guys set up for the next part of today, which is to go over our notes for reaction mechanisms today.